The German engineer stood alone in the cold morning air of the Kummersdorf proving grounds, running his hands slowly along the sloping hull of the American tank. Something was deeply, unsettlingly wrong. It was not a mechanical fault with the machine sitting before him, but rather a fundamental error in everything he had been told about the capabilities of American manufacturing. It was April 1943, a turning point in the war, though few realized it yet. The tank, bearing the serial number USA 3067641 and the hand-painted nickname War Daddy 2, had been captured in the burning sands of Tunisia 2 months earlier. The German High Command, desperate for an edge, had demanded a complete forensic evaluation. They needed to know the M4 Sherman's weaknesses. They demanded firing tables showing exactly where a Tiger or Panzer IV should strike to ensure a kill. The engineer had spent 3 exhausted weeks examining every bolt, every rivet, and every plate of steel. He was looking for flaws. He was looking for the incompetence that German propaganda claimed was inherent in American engineering. But what he found was not weakness. As he ran his trembling fingers over the hull welds, he felt a terrifying precision. These weren't just strong connections. They were clean, uniform, and unmistakably machine-made. It wasn't just a manufacturing philosophy that terrified him in that moment. It was the dawning realization of an industrial disparity. While Germany was painstakingly crafting armored masterpieces by hand, treating each tank like a singular work of art, America was printing tanks. They were churning them out with the same ease and speed with which a bakery produces bread. War Daddy 2 had been captured on February 22nd, 1943, just 8 days after the catastrophic Battle of Sidi Bouzid began. That engagement had been an absolute disaster for the inexperienced American forces. Veteran German panzers had smashed into the US 1st Armored Division, shattering their lines and sending them reeling back in panic toward the Kasserine Pass. This specific tank belonged to Company G, 3rd Battalion, 1st Armored Regiment. In the smoke and chaos of the retreat, the crew had abandoned it. Perhaps they ran out of fuel in the frantic withdrawal. Maybe a lucky hit had disabled a track, leaving them immobile. The official records are silent on the crew's fate. However, what the records do state, with chilling clarity, is that German recovery teams found the Sherman completely intact. And here was the first shock. Unlike most captured enemy vehicles that required extensive repairs or towing, this American tank started on the first try. The engine roared to life without hesitation. The Germans then drove it over 200 miles to Tunis. They pushed it for 4.5 days across the brutal, scorching desert terrain. There were no breakdowns, there were no mechanical failures, no overheating. They simply drove it, loaded it onto a ship, and sent it to the heart of the Reich. High Command wanted their absolute best engineers to tear it apart, piece by piece. But what those engineers found inside the belly of the beast would fundamentally change how they understood the war they were fighting. Kummersdorf was not just a testing ground, it was the premier weapons facility of the German Empire. Located 20 miles south of Berlin, hidden among the trees, it had been the birthplace of the German rocket program and the testing ground for every major Wehrmacht weapons system. The most brilliant mechanical minds in the Reich worked here. These were the men who had evaluated captured Soviet T-34 seconds in 1941, panicked by the sloping armor, and helped design the Panther tank as a direct response. Now, they had their hands on their first operational American medium tank. Initial expectations among the staff were incredibly low. German intelligence, blinded by arrogance, had dismissed the Sherman as a crude, mass-produced, inferior design. They mocked its high profile. They scoffed at its thin armor and what they perceived as a weak gun. It was, in their minds, built by a nation of shopkeepers who had never fought a modern tank war. The engineers approached the Sherman with the arrogance of master artisans inspecting a cheap, counterfeit knockoff. They expected to find sloppy welds that would crack under pressure. They expected brittle steel that would shatter upon impact. They wanted to laugh at the crude American attempt to build a war machine. They had their fountain pens ready to write a scathing, mocking report that would make the generals at High Command smile. They started with the armor, measuring every plate with calipers, calculating every angle of incidence. They stenciled the numbers directly onto the olive drab hull in stark white paint. The findings were underwhelming. The armor thickness was adequate, but certainly not impressive. It measured 51 millimeters on the front hull and 38 millimeters on the sides. A German Tiger tank could punch through that protection at over a mile away. The engineers felt vindicated. Then, they opened the rear engine compartment. The Continental R-975 radial engine sat in the rear of the hull, looking strangely out of place, like an aircraft engine that had been dropped into a tank chassis. Because, as the engineers realized, that is exactly what it was. The Americans, prioritizing speed of production, had taken a proven, existing aircraft power plant and adapted it for armored use. It was 400 horsepower, air-cooled, and designed for absolute reliability at high altitudes where mechanics couldn't reach it. The German engineers noted the power-to-weight ratio immediately. The Sherman weighed 30 tons, and the engine gave it nearly 13 horsepower per ton. In comparison, the fearsome Panther weighed 45 tons but was powered by a 700 horsepower engine, yielding only 15.5 horsepower per ton. The massive German cat had barely more agility than the smaller American tank, despite weighing 50% more. But raw power wasn't what impressed the men at Kummersdorf. Any industrialized nation could build a powerful engine. What stunned them, what made them call their colleagues over to look, was the maintenance access. Every major component of the American engine could be reached through large, accessible hatches. Oil changes took minutes. Spark plug replacement required no special tools. A farm boy with basic mechanical training could keep this engine running indefinitely in the middle of a muddy field. German tank engines, by contrast, were prima donnas that required factory-trained specialists for routine maintenance. The Maybach HL-230 in the Panther was notorious for cooling problems that caused spontaneous engine fires. Replacing one required a crane, a dedicated workshop, and a full day's work. The Americans had built a tank that could be serviced in the field by the crew. The Germans had built tanks that practically needed to be shipped back to the factory for an oil change. The engineers kept examining, digging deeper into the machine's guts, and it kept getting worse for them. It was the sound that finally stopped them in their tracks, or rather, the lack of it. When they ran the powertrain, the German engineers were accustomed to the screaming, metal-on-metal whine of spur gears fighting against friction. The Sherman, however, hummed. One engineer, disbelief etched on his face, called his superior. They were looking at herringbone gears. These were precision-cut helical teeth that meshed smoothly under load, distributing stress evenly. These were the kind of gears that could last for thousands of miles without wearing out. German tanks used spur gears, straight-cut teeth that were cheaper to manufacture and easier to cut, but which wore out quickly under the immense stress of combat driving. The reason for this disparity was simple, but devastating. Herringbone gears required complex, multi-axis machining and specialized gear-cutting tools that Germany simply lacked. Furthermore, the tooling required tungsten carbide, a strategic material in critically short supply due to the strangling Allied naval blockades. Germany had been forced to revert to inferior spur gears to save manufacturing time and reduce tooling wear. The result was a logistical catastrophe. The Sherman's transmission could handle 3,000 miles before needing an overhaul. The Panther's final drive had an average lifespan of around 150 kilometers less than 100 miles. A Sherman could drive from the beaches of Normandy to the streets of Berlin under its own power. A Panther could barely make it from the railhead to the front lines without shattering its transmission. The engineers dutifully documented everything, their arrogance replaced by a growing sense of dread, but they weren't prepared for the next discovery. The 75mm gun had a small, unassuming box attached to its mounting. Electrical cables ran from it to a gyroscope situated near the gunner's position. It was a gun stabilizer. The Americans had successfully installed a delicate gyroscopic stabilization system in a mass-produced tank. The German engineers were astounded. They had experimented with stabilizers for years, but had never managed to miniaturize the components enough for practical tank use. The precision required was beyond their strained manufacturing capabilities. The American Westinghouse system wasn't perfect. It only stabilized in the vertical plane and didn't allow for true shoot-on-the-move accuracy in the modern sense. But it did something far more valuable in 1943. It kept the gun roughly on target while the tank moved over rough terrain, which meant the gunner could fire accurately within seconds of the tank stopping. German tanks, with their heavy, unstabilized guns, needed 10 to 15 seconds for their suspensions to settle and the gunner to reacquire the target before they could fire. In a lethal tank duel, the first accurate shot usually won. The Sherman could get that shot off before a German tank had even stopped bouncing. The Germans examined the gyroscope and the tiny servo motors. They calculated what it would take to replicate the system across their own fleet. The answer was a silent, terrifying admission. They couldn't. Not with their current industrial base. Not with the materials available. Not with the precision manufacturing capacity they had left. And yet, they still hadn't discovered the worst part of the story. In June 1943, War Daddy 2 was transferred to Hillersleben for a demonstration before the High Command. The generals didn't want a reliability test. They wanted a show. They wanted a spectacle. Senior officers from across the Wehrmacht gathered to watch generals who controlled armored production priorities, men who would decide whether to keep building Tigers and Panthers or change course. They set up a climbing test. A steep, 30-degree slope of loose, shifting sand. The Panther went first. The German tank roared up the hill effortlessly. Its wide tracks distributed its weight perfectly, biting into the sand. Its powerful engine never strained. It crested the hill like a predator. The generals smiled, nodding to one another. This was German superiority. Then came War Daddy 2. Its narrower rubber block tracks, designed for long road marches and bridge crossings, slipped on the loose surface. The engine whined as the driver gunned it. The tracks spun helplessly, digging holes in the sand. The tank slid backward. Defeated, the Sherman failed to climb the hill. The generals applauded. The demonstration had proven exactly what they wanted to believe. American equipment was inferior. The failure on the hill at Hillersleben was a disaster, but not for the Americans. It was a disaster for the Germans. The generals looked at the hill and saw a victory. The engineers looked at the transmission and saw a warning. The Panther had won the sprint, but the engineers knew it would never survive the marathon. While the Sherman couldn't climb that specific sandy slope, it had just driven over 200 miles across the Tunisian desert under its own power to get captured. It was a feat the Panther could rarely match without breaking a final drive. The hill climb validated every wrong instinct the German military had. It convinced them to keep building high-performance thoroughbreds instead of reliable workhorses. The engineers who had spent weeks inside War Daddy 2's engine compartment knew the truth. But they had just watched their generals cheer as the Sherman slid backward on loose sand. Nobody wanted to hear that the American tank's failure on the hill meant nothing compared to its success in getting to the hill in the first place. And then Albert Speer came to see for himself. Albert Speer was the Reich Minister of Armaments, the second most powerful man in the German economy. He controlled all war production. Every tank, aircraft, and submarine built in Germany came under his authority. Speer had a reputation for ruthless efficiency. He had tripled German weapons production in 1942 through reorganization and streamlining. He believed German engineering could outproduce the Allies if properly managed. Photographs exist of Speer examining War Daddy 2 at the testing grounds. He studied the reports. He talked to the engineers who were afraid to speak to the generals. And he reached a conclusion that would haunt him for the rest of his life. Speer later wrote in his memoirs that reports from the Italian front praised the Sherman's cross-country mobility. The American tank climbed mountains that German experts considered inaccessible to armor. The engine's power-to-weight ratio gave it superior agility on level ground compared to the lumbering German designs. But Speer understood the deeper, more fatal problem. Germany was building complex, delicate machines that required a dedicated rail network to move anywhere. America was building a mobile force that could drive itself to the front line. Speer realized that no amount of German engineering genius could overcome a logistical philosophy that was simply better. The Sherman wasn't just a tank, it was a philosophy made steel. American industrial philosophy prioritized three things: reliability, maintainability, and mass production. German industrial philosophy prioritized one thing: technical superiority. American designers had made different choices. They accepted a less powerful gun because the 75mm was reliable and ammunition was plentiful. They accepted thinner armor because it reduced weight and improved mobility and fuel range. They accepted a simpler design because it meant faster production and easier maintenance. Germany couldn't compete with that. Not because German engineers weren't brilliant, but because German engineers had optimized for the wrong things. The men who understood this reality best weren't the engineers in Berlin, they were the tank crews on the front lines. Alfred Rubbel commanded a Tiger I in the 503rd Heavy Panzer Battalion. He eventually became a tank ace with 57 confirmed kills. He knew exactly what German tanks could and couldn't do. His unit frequently used captured Shermans for recovery and supply duties because their own vehicles were too unreliable. Rubbel later compared the Sherman to a reliable civilian car. You push the button, and they started, he said. With the Tiger, there was always a ritualistic procedure: checking fluids, warming up the engine carefully, worrying about the fragile transmission. The Sherman just worked. German tank crews loved their Tigers and Panthers when they worked. The problem was, they rarely worked when needed most. By 1944, German armored divisions reported operational readiness rates of 35 to 45%. More than half their tanks were broken down at any given time, sitting uselessly in repair depots. American armored units maintained readiness rates above 85%. When the Americans needed tanks for an offensive, they had tanks. When the Germans needed to counterattack, they had repair orders. The numbers told a story that German propaganda tried desperately to hide. The Normandy campaign proved everything the Kummersdorf engineers had feared back in 1943. During the frantic retreat from Normandy, roughly half of all abandoned Panther tanks had been destroyed by their own crews after mechanical breakdowns. They weren't lost to enemy fire, they were lost to faulty transmissions and overheating engines. Imagine the frustration, the rage, of a German panzer crew. You have the most powerful gun on the battlefield, you have the thickest armor, but you are standing on the side of a road in France, striking a match to burn your own tank because the transmission is smoking, all while a column of inferior Shermans drives past you to win the war. They didn't lose because they were outfought. They lost because they couldn't even get to the fight. The statistics from the Battle of the Bulge were even worse. By late 1944, 60 to 70% of German heavy tank losses were non-combat related. Fuel shortages and breakdowns claimed more Tigers than American gunfire ever did. The engineers at Kummersdorf had seen this coming in April 1943. They had looked past the showy, deceptive hill-climbing demonstration at Hillersleben and focused on what actually mattered: the internal components, the manufacturing philosophy, the brutal mathematics of reliability. They had documented every advantage the Sherman offered. They had written reports explaining exactly why American mass production would win the logistics war, but nobody had listened. The generals had been seduced by the spectacle of the Panther roaring up a sandy hill. They had cheered as the Sherman slid backward, mistaking a traction test for a war simulation. Nobody wanted to hear the quiet warning that the American tank's failure on the hill meant nothing compared to its unprecedented success in getting to the hill in the first place. And then, standing in the shadow of that captured machine, Albert Speer came to see for himself, and in the silence of the proving ground, he heard the sound of Germany's inevitable defeat.